let's talk about another factoring technique for quadratics called completing the square. And some people love this technique, some people hate it, but I think it is necessary for us to go over it because AOPS uses this method in a lot of their problem-solving techniques. Personally, I don't love this method because if I can't factor something very nice and easily, then I immediately go to the quadratic formula. But we do need to go over completing the square so that when we hit it in AOPS, we know what we're doing. So let's take a look at this first problem. And first of all, here are the steps because we love steps. So step number 1, subtract c from both sides. And what is this talking about? This is talking about when we have a quadratic equation in our standard form of ax squared plus bx plus c equals 0. When it is in this form, a would be the coefficient of our x squared term, b would be the coefficient of our linear term, and c is our constant, equaling 0. We're going to subtract c from both sides. We're going to first of all make sure our next step is that a, our coefficient of our x squared term, is 1. If it isn't 1, we're going to divide everything by whatever that coefficient is so that we can get just 1x squared. Then we're going to find half of b, this linear coefficient. Then we're going to square that. Then we're going to add that to both sides of our equation. So add it to the left side, add it to the right side so that both sides can be equal. Then we're going to factor the left side of the equation because when we add it to both sides, we're going to end up with a perfect square on this side, and so we can factor out this perfect square. Then we're going to take the square root of both sides, and then we're going to solve for x. So let's see how that plays out in our first example. And this should be x squared plus 10x minus 24 equals 0. That 0 just didn't copy right. So the first thing that I would do here is I would not jump right to completing the square. I would say, can I factor this out easily? So I'm looking for factors of negative 24 that are going to add or subtract to get 10. And I immediately know, oh, positive 12 and negative 2. So if I were just to factor this out, I would get x, let's see, plus 12 and x minus 2 equals 0. And when I solve for that, I'm going to get x equals negative 12 and x equals positive 2. Well, that was a really easy way to solve it. So I would not use completing the square for this method, for this problem. However, let's go ahead and just practice the completing the square process on a really nice, easy problem before we get into some problems that you might actually consider using this method for. So step number 1, we're going to subtract c from both sides. Now c in this case is negative 24, so I'm going to add it. I just want to get rid of that constant. So I'm going to add 24 to both sides. And I get x squared plus 10x plus 0 equals 24. Step number 2, I'm going to make sure that a is 1, and I do have no coefficient in front of my x squared term, so I'm just going to skip step 2. I don't need to do it. Step 3, I'm going to find half of b. Oops, I've needed x right there. Half of b is this positive 10, so half of 10 is 5. Step 4, I'm going to square that. So 5 squared is 25. Step 5, I'm going to add 25 to both sides of my equation. So now I have x squared plus 10x. I'm going to add 25 equals, and I had 24, and I'm going to add 25. So I just added 25 to both sides of my equation. Step number 6, I noticed that on the left side, this is going to factor out to be a perfect square. When I factor this is going to turn out to be x plus 5 times x plus 5, which I'll just write as x plus 5 squared. And I'm going to go ahead and simplify my right side. 24 plus 25 is 49. And right now I'm going, oh, that's also a perfect square. Step 7, now I want to simplify this because my goal is still to get x by itself. X equals something. So I'm going to take the square root of both sides. And I'm going to end up with x plus 5 equals, the square root of 49 is 7, but it has to be the positive and negative 7. And then step 8, now I can solve for x. I'm going to subtract 5 from both sides. and I'm going to get negative 5 plus or minus 7, which I can simplify. Negative 5 plus 7 is 2, and negative 5 minus 7 is negative 12. So x equals 2 and negative 12, which, when we factor this out using the much simpler method, we also got that. So that is how to factor this problem using completing the square method. Let's go ahead. You try it for this problem. Factor it first to see if it factors nicely, and then go ahead and do the steps for completing the square to see if you can do the steps. Let's go ahead and try completing the square for a problem that's not going to factor quite so well. So let's take 4x squared minus 4x minus 11. Now, I have a 4 in my coefficient, so I immediately know this isn't going to factor nicely quite as easily, but I could go ahead and try it. I could do 4x and x equals 0, and I'm looking for factors of negative 11 that are going to combine. And if I put 11 here, I'm going to get a 44, which is way too big. If I put 11 here, I'll get a 4 and an 11, but that will not come out to be a 4, so that won't work. I could do 2x and 2x, then it wouldn't matter where I put my 1 and 11, but I'm going to get here 2 and 22, and that's not going to work to get 4. So I know that factoring this out using just kind of our basic method, this is not going to factor out nicely. Now personally, from here, I would jump straight to quadratic formula, but let's go ahead and practice using completing the square just so we can get this, this method under our belt. So step number 1, we're going to go ahead and subtract, or in this case add, our constant to both sides. Now step number 2, we have to make sure that a, the coefficient of our quadratic term, is 1. It's not 1. So we're going to divide this entire equation by 4. I'm going to divide the left side by 4 and the right side by 4. So now my left side, since I'm dividing it by 4, is now x squared plus 1x equals, and then I'm just going to keep this as 11/4. Now that I have 1 as my coefficient for my quadratic term, now I'm going to go ahead and continue. We're going to find half of b. Well, what is my invisible coefficient in front of my linear term? It's 1. Half of 1 is 1/2. Now we're going to square that. So 1/2 squared is 1/2 times 1/2, which is 1/4. We're getting fractions. Have no fear. Just plot on. Step number 5, we're going to add 1/4 to both sides of this equation right here. So I have x squared plus 1x plus 1/4 equals 11/4 plus 1/4. Now I'm going to go ahead and factor this. And again, I'm looking for factors of 1/4. They're going to add or subtract to get 1. Well, and I know and this should factor out to be a perfect square. So this is going to be x plus 1/2, because 1/2 times 1/2 is 1/4. 1/2 plus 1/2 is 1. Oh, and look, I'm adding this right here. When I factor it, it turns out to be that. And this is going to be squared equals, and then 11 plus 1 is 12/4, which I'm just going to go ahead and simplify right away to be 3. Now, this is looking interesting, and now I can see why this did not factor out well. I already am going to have a fraction, and when I take the square root of this, that's not going to turn out so nicely. So I'm going to take the square root of this, and I get x plus 1/2 equals the square root of 3, positive and negative root 3. I'm going to subtract 1/2, and now I get x equals -1/2 plus or minus root 3. And you can definitely see why this did not factor out nicely. Now, if I want to put this I could write it like that, but a lot of times we don't want a fraction, and then I'm going to put everything all together. So I'm going to kind of go up here. I'm going to rewrite square root of 3 as something over 2, so I can have a common denominator. So I have -1/2 plus or minus 2 root 3 over 2. And we can see that these 2's cancel out to simplify to be just the square root of 3, but now I can combine them. So now I have -1 plus or minus 2 root 3 all over 2. And here are my two solutions for this problem, just written as one fraction. And especially with a problem like this, I would probably want to check my answer. And probably the quickest way to check my answer is just to convert these two into a quick kind of rough decimal. Because really, I don't want to find the exact, I just want to get am I on the right track? So I converted these to a decimal using my calculator. Oh, and I think if my memory serves me right, I got I want to say -2.232 and 1.232. It was something like that. And I just went ahead and plugged those into my equation, and I roughly got approximately 0 for both of them, so I knew that I was on the right track. All right, for this problem here, go ahead, see if you can factor it out the quick way. Hopefully you should be able to, and then go ahead and practice using your completing the square steps, just so that we can do some more practice with completing the square. Now again, completing the square, this is a little tedious. If I were just going to go ahead and have to factor this out, I could go ahead and factor it out the easy way. That would be my first check. My second check, if it doesn't work, personally, I would go straight to the quadratic formula. But we do want to know and be aware of this method for completing the square, because AOPS uses it a lot in their problem solving. So we just need to be aware of what that is so that we could have another tool in our tool belt for solving tough problems.